The second way that they are going to measure the spring constant is dynamically. What they're going to do is they are going to add a certain amount of weight to the hanger. In this case, they have to include the mass of the hanger because the hanger is oscillating along with the weight that's added to the hanger. So make sure the students realize that they need to add the 50 grams of the hanger in addition to whatever additional mass they put on there. What they're going to do then is once they have a certain amount of mass that they've added, they're going to pull the mass down just a little bit and then let go. The mass becomes a simple harmonic oscillator, and the period, the period will basically, the square of the period will be proportional to the spring constant. So what they're going to do is they're going to take a timer, and they will, a timer that works, and so they will, upon the student who's ready to do the timing, what he should or she should do is start the timer, and then once there have been 10 oscillations, they stop the timer. Okay, and they just read how long it takes for 10 oscillations. If it takes 30 seconds for 10 oscillations, that means each oscillation is 3 seconds and the period of oscillation is 3 seconds. What they'll then do is they'll plot t squared versus the mass on a piece of graph paper, and that should form a straight line, and that straight line would be equal to 4 pi over the spring constant. Okay, so what they have to do is they have to, they'll do that, for example, they'll measure how long, the period for that, square it, graph the square, they'll add more weight, and again, whoops, they should be careful, try not to make any horizontal motion. There might be a little bit of horizontal motion, but they should try and minimize that. And again, they'll time it. Of course, more mass means a longer period, and so it'll take longer. So instead of 3 seconds per oscillation, it may take 3.5 or something like that. But they'll do that for five different masses, 5 different periods of oscillation, and they will graph that. On the vertical, you'll have t squared. On the horizontal, you'll have the mass. And then the slope of that line should be 4 pi over the spring constant. Okay, so they can measure the spring constant, because hopefully it'll be a straight line, or pretty close to linear. Then they take 4 pi over the slope, and that will give them k. Okay, so that would be the dynamic way to measure the spring constant. Then they can compare that value with the value they initially measured from stretching the spring.
Okay.
Okay.